Thanks, everyone. For those who don't know me, I'm Ben Nucci. I'm the Vice Chair of Allotrope. And I will be taking you into the next part of the agenda. So our first talk of the day on implementation comes from really Merck's a Merck ZONTAL collaboration. Our first effort to move, as Jen laying out in the introductory comments, thinking about different domains that we need to move into, in addition to the instrument domains that we've been looking at for some time. I'm good at keep talking. And our first speaker, it's going to be a dual talk. Our first speaker will be from Merck, Sreeni Yetukuri. Sreeni's an associate director in IT with over 25 years of experience. I've been working with him, I know, when I was in the business areas, the electronic notebooks. So he's going to tell you about the business drivers behind moving off our electronic notebook to a new platform and archiving that legacy data. And then Spencer Gardiner from ZONTAL, he's a data scientist, and he will take us through the actual implementation and do a product demonstration for us.
Good morning, everyone. We are all familiar with our notebook. For even we use one at some point in our career. So the electronic notebook start ELN, Laboratory Information Management System claims. Basically, what the first two applications implemented decades ago began the transition from a paper-based laboratory environment to a digital environment. For the past 20 years at Merck, our lab notebook application in the center of our digital ecosystem. Scientists can experience numerous benefits from utilizing an lab notebook ELN as highlighted on the left side of the slide. Data can be captured in a way that acts secure and control, which helps safeguard critical property. Additionally, ELNs have potential to systematically organize data, making it easier to search for other applications. However, the lack of agreed upon device and architecture patterns across commercially available have resulted too much to maintain. Have resulted in only partially connected ELN ecosystem that is and cost too much to maintain. As the digital landscape evolved, the role of ELN has changed. They are becoming an integral data-driven ecosystem enabling analytics. Enabling the analytics and collaboration. For a few minutes, I'm going to take you through the Merck's journey to modernize notebook and configure. Sorry. So basically, I'm taking you through the Merck's journey to converting, like moving into the ELN archive system.
Yes.
For the next few minutes, I'm going to take you through Merck's journey to modernize our electronic lab and configure positively contribute to our data ecosystem. So Merck implemented a Cambridge software book. Now they call it Revity. Cambridge is no longer there. Approximately 2000 and about the past 20 years, over 30 terabytes of data have collected across 4 main configurations that are in a little bit. However, the software had become quite fragile and unreliable over the time for our scientists. So we decided to move our nearly 6,000 users to a modern cloud native ELN, selected this signal book. The UI is quite flexible and highly configurable. It was important to Merck, so we could embed key ontologies and data structures in modular templates, so we could build the solution. We also evaluated the platform as a potential solution to represent not only ELN data, but also as a solution to archive legacy components of ELN data into a consistent and independent format. Let's take a look at the goals Merck had for its legacy ELN and legacy archive and requirements for a successful solution. So the most important aspect of an R&D organization is its intellectual property, and a good deal of these learnings for 2 decades were captured in our legacy. Therefore, it was our goal not to represent this in a compliant manner, that protect our intellectual property, also to ensure that we preserve this knowledge with provenance and traceability. Additionally, to maximize the value of the data, it must be represented with consistent context and structure to ensure it is reusable for scientists throughout the organization now in the future. To meet our data lifecycle integrative policy. Fit in our evolving ecosystem, deliver a great user experience and meet overall financial requirements. The solution also had to drive data interoperability and forming legacy data silo. With this goal in mind, high-level requirements were developed to select a solution among internal and externally available card solutions. So looking into the high-level requirements, we basically put in 2 buckets, one for the notebook archive, the other one is in the analytics. Some requirements are common for both of them, that's called as universal requirements. If you look into these requirements, data integrity is the key, and also the time data must be stored in a vendor node format. So some of the notebooks archive requirements look into this. One is the ability to access experiment in its version. So a lot of this archive solutions we look at the presentation missing. The databases can be kind of stored like archived, but you are missing the key part presentation layer. That is one thing. The other thing is also the solution must be part of the compliant 11, 21 CF part 11 and 50 lines. Okay. So our evaluation of the multiple solution options, ZONTAL selected for ELN data archive solution. This solution fits into the integration and governance layer to help create data sets cloud as a source for downstream last mile applications. Natively supports Allotrope technology to contextualize structured data and unstructured data, which was to Merck since we were already in the Allotrope standard for instrument data at an enterprise. So let's take a closer look at the rest of the data of our legacy ELN that ZONTAL is helping us to standardize in a format. Actually, not only Cambridge Soft or WTL, and we are also currently working with ZONTAL to convert this into ZONTAL for the biodata lab and also Michelin. So, ELN data is organized in the hierarchy, represented on the left-hand side of the slide through experiment templates. Each experiment may be composed of sections. The kind fields are the kind fields which are used in data. The majority of these fields include structured data, but percent are unstructured. From the slide, you can see how many templates and fields can be found. There are 4 main configurations in production. The first was creating a suitable data model to capture this overall structure and a scaffold for future ontology model to be built from. The representation of this, like if you look into the other side, the basically you have like the legacy ELN data structures, where approximately 254 different tables. The complexity comes with the data stored in the audit trial. The unit of this by John as depicted of this slide. This entire model, the many tables into 10 reusable components containing approximately 134 properties. This is approximately 24 consolidation to simplify the representation of data. As we speak, this draft of the ELN data model is being used to standardize ELN data for the next few months. The plan is to we kind of 30% of the data will be migrating into the ZONTAL band of this C, remaining 70% in the first test year. So, however, in decide also to submit model to Allotrope for governance as a start for an experiment domain model for ELN. As a result, Allotrope created an ELN working group which started working on the components. The of meetings, it was decided that ELN model will be developed in increments. For 2024, build of an ELN model based on the ZONTAL condition. This is able to create a consistent high-level structure for ELN experiments search and data lake ingestion use cases. In parallel, the ELN group will begin design a stable modeling approach, the next level of structure within the ELN to structure the content within each content and it is decided in the shell to explore deeper semantics exploration. First example will be materials input tables that are in nearly every ELN experiment and reaction tables in all experiments. The goal to use this to be a model design strategy in 2025 and then release the expanded ELN model in 2025 to enable ELN analytics use cases. I will hand to my colleagues to describe their product and how we are going to solve the ELN problem. Mark, Spencer.
All right, everyone. I'm Spencer Gardiner. I'm a data scientist at ZONTAL, and I'll be going into a little bit more detail about the work that we've done with Merck on the electronic lab notebook. Okay, so the first thing I want to do is go a little bit deeper into the proposed ASM structure to help y'all get a better feel for what this actually looks like. First thing I want to highlight are these 4 arrows right here. So this proposed ASM format really heavily leans into the save a path to a file, not the file itself, paradigm that the ASM standard follows. Because ASM is JSON based, it's much simpler to just save a path to an outside file, be it video, audio, PowerPoint, etc. And so for these ASM files, section, field, and table cell documents will sometimes save audio visual data, but more often than not, they'll take PDFs and then Microsoft Office files, PowerPoints, Excel spreadsheets, Word documents, etc. are linked here so that you can see your attached files from within your ASM document. We also see these, or this table cell document right here. The thing to note here is that ELN data is very diverse, and especially when you take into account the different kinds of data sets that people work with, the stuff you try to display in a table just varies super widely. So what we decided to do is move each cell in a table into its own document so that we could better have the flexibility needed to display varying data types. These internal arrows that we see here are internal references. So each object within your ASM file has a key that can then be used to allow one object to reference another. So table cells, fields, and sections can all reference a chemical structure document. And then that chemical structure document can point to outside files such as ChemDraw files, an SVG, or a reaction file. And then lastly, down at the bottom, we see the audit trail document. In addition to just saving like a signature log, we also can track changes that were made to the ELN object or to the objects within an ASM file over time, so that in a viewer, you can recreate previous versions of your ELN and see changes that were made and who made them. All right, so what does this look like in the ZONTAL platform? I'm sure most of you have seen this before, but for those who don't, or who haven't seen this, this is the ZONTAL platform. ZONTAL is the leading data management platform. We take data from any producer, transform it into a vendor-neutral format, and then broker it to any possible consumer. This is pretty cool. For ELN specifically, ELN data is just another data producer. So whatever your type of ELN data is, we take it, transform it to that ASM format, and then feed it out to whichever data consumer you want to have access to that data. This could be your own data lake, your own data analysis dashboards, APIs, or ZONTAL's data viewer. So if we go here, look at a recorded demo. Okay, so what we're looking at here is first a chemistry ELN. So we see here that we have multiple metadata fields that can be extracted from your original ELN. We're able to set retention tags and maintain your original access compliant or access policies and update those as well. And then we're able to launch the viewer. Let's see. Okay, just give it a sec. So we can then launch the viewer, view your ELN archive data. So as a quick note, this ELN archive viewer is not built around the products from any one specific vendor. Rather, we try to create something that could be pretty universal and work with a wide variety of ELNs and present data well. On the left-hand side up here, you see this tree view. A typical ELN will have multiple projects and experiments. And so this tree view allows you to expand out and see all the various subfolders in a given data set. And the one you select is highlighted. So this is dummy data. We don't have all of the nested experiments here, but this is where they would be if you were looking at your own data set. Under selected entities, you're able to select things or documents that you want PDFs created for. Now as we go down, we're able to see a reaction loaded from the original ELN, hover to see it in more detail. And then as we go down, we see tables with reactants products. The thing to emphasize here is that all of the data that was in that original, in this case, Cambridge Soft ELN is loaded. And then, sorry, ahead of myself. When we open up this observations tab, we're able to see an attached Word document, view it within the viewer itself, and then you have the option to download your attachment into the native format, file format if you so choose. And then lastly, as we keep going through, we can access the audit trail. And then again, here we can see when edits were made, who made them, and then on the left-hand side, we're able to select different versions to view and interact with them within our archive viewer. Now onto a bioassay ELN. So once again, reagents, products, all of the data from your original ELN is viewable. It's accessible. You can see it and access it pretty easily. Hyperlinks, all of that stuff is preserved in our ELN archive viewer. And then because we're dealing with biodata, we have a plate well viewer where we list multiple plates. You select the one you want to view, and the wells update. All of your data is there, and it's easily, intuitively accessible. So that right there is our ELN archive viewer. Now, ELNs are cool and all, but I'm sure the question that's on everyone's mind is, when are you going to start talking about generative AI? Well, we're here. Okay, so the issue with ELN archive data is that there's just so much of it, and it's old. Maybe it doesn't have all of the metadata that you care about now. Maybe it wasn't properly indexed when it was created. Who knows? Our solution at ZONTAL is a large language model-based insights assistant that understands your ELN data. So this uses RAG, retrieval augmented generation, to intelligently respond to user questions and help you extract new insights from your hard-won data. I mean, this is your intellectual property here. You spent millions of dollars to extract this information and then millions more to maintain it. You deserve to be able to get new insights out of it and leverage that data for your current problems. And that's what the Insights Assistant seeks to assist you in doing. So in ZONTAL's platform, the Insights Assistant just builds on the existing platform. We take that ASM formatted data and are able to process it and help you better understand what's in your data and what you can do with it. Oh, sorry, let me go back. Okay. Another quick note, the Insights Assistant can use an arbitrary LLM model. If you want the latest and greatest from OpenAI, we can make it happen. If you don't trust them to see your data and want something that's completely in-house, we're able to use your open source model of choice, whether that's Llama, Mistral, or something else. We're able to customize the Insights Assistant to meet your business's needs. So who benefits from this? Well, let's look at a couple of use cases. First one, for a manager who's looking at working with a team of scientists, you can ask what types of experiments are performed, who performed them, how long it took to run a certain experiment, etc. A scientist could potentially look back at old work that they kind of remember but are fuzzy on the details and get a summary of it, and then ask follow-up questions. Okay, what was the procedure done? What were the results for this piece of data, etc. A data scientist can use the Insights Assistant to figure out, okay, what data sets would do well to be fed into a machine learning or analysis pipeline? What do I need to do in order to clean up that data? The Insights Assistant is able to help people in a wide variety of roles to streamline their workflow and use their ELN data effectively. All right, now on to demo number 2. So this is a synthetic data set that was generated by ChatGPT, but does well enough for our purposes. So first question, what projects were performed? We get a list of the projects that are included in this data set, and then scientists that contributed. And then a follow-up question. Okay, what did this scientist, Olivia Martinez, do? What experiments did she conduct? And yep, we get an answer. And then we can ask a follow-up question again. Okay, what were the results of her experiment? And then again, we get a short answer. And then from there, we could ask another follow-up question or look at the original data in the ELN archive viewer if we wanted. And then from a data scientist perspective, Okay, in this ELN, which data sets could be used to train a predictive model? We ask it, and then we get a response of, here's a couple of data sets that you could look at, gene expression or I believe it's vaccine development. And then we can ask a follow-up question. For gene expression, what would be some good features and labels to train on? What would be the inputs and the outputs that we're trying to predict? And then again, we can ask the question and then get an answer back out. So the Insights Assistant, whoops. The Insights Assistant is able to help a user better understand their data and also suggest how that data can be used in future projects. All right, so key takeaways. First of all, ASM is the future of archival ELN. It's moves your data out of silos. It's accessible, fair, standardized. It's pretty cool, and it's coming soon. Next, ZONTAL's ELN archive solution is ready to go. Admittedly, we're working with the preliminary ASM model, but it's ready. It can be deployed to your environment, integrated with your ELN viewer, and let you hit the ground running. We're GXP compliant, whole 9 yards. We're ready to go. Not only that, but we have this Insights Assistant. I mean, think about it for a moment. We have generative AI that's like actually useful, actually understands what your data is, what your problems are, and can help you to speed up your workflow and, like I said before, get insights out of your hard-won data. You deserve to, you deserve to have intelligent help coming out of the data that you work so hard to collect, instead of just letting it sit in a SQL database somewhere. And that concludes my presentation. Thank you very much.